So standard 9 gives us that the region R is bounded by the x-axis, the graph of f of x equals root x, and the line x equals 4. And so I made a quick diagram over here, if you can see. This is the outer bound of the graph of y equals root of x from the point 0, 0 to 4, 2, because it says R is bounded by the x-axis and the line x equals 4, and where that intersects the graph of root of x is at the point 4, 2. And so the first part A, asked to find the average value of the function f in the region R over here. And so previously we learned that the average value of any function from x values a to b is 1 over b minus a, or in this case 4 minus 0, right? The minimum value, x value is 0, and the maximum is 4. And then 1, so in this case it will be 1 over 4 times the integral of root of x dx, or the function from a to b, or 0 to 4 in this case. And so when we take the antiderivative of this function in the integral to solve it, we get 2/3 by the power rule, 2/3 x to the 3 over 2 power. And then when you multiply that by 1/4 and plug in 4 for your final x value, and then imagine that there's all of this times 0 over here, which just comes out to 0, subtracted. So you can just cancel it out. So this value comes out to 1/4 times 16 over 3, or 4 over 3. So the average value of f in R is 4 over 3. And then for part B, it asks to find the area of R. So the shaded region is going to be the area of R. And the how you use integrals to find the area between a graph and the x-axis, like we learned, is to go from the initial x value to the final x value, and then that integral of the function, and then dx. And so when we solve for this, based on our work over here, we're going to get the same antiderivative, but it's, instead of taking that value, 2/3 times 4, to the 3 over 2 and dividing it by 4, we're just going to keep it. So that the area under this graph, in between that graph and the x-axis, is 16 over 3.